Hello and welcome to Contemporary Math Lesson 2B, Problem Solving with Units. So putting unit analysis to work. I talked about in the last lesson how we use unit analysis, and here's how we can use it. So we can identify the units in the problem and the units you expect for the answer, determine the operations needed, either multiplication or division, make sure your answer has the units you expected, and then the last, and this is really the most important, as we'll see in the first example here, does your answer make sense? Well, we're just going to see if these sentences make sense. And I think this first sentence here for part A might be my most favorite sentence in the entire course. I know someone who can run 35 liters per second. That makes no sense whatsoever because liters is a measure of volume. And most people know that liters is some sort of measure for how much you're drinking. Maybe you've heard liter cola from Super Troopers, but this is not a distance, and that makes it a problem. So take a few seconds, look at the rest of these, see if these make sense, and have some backup. If they make sense, okay. If not, why not? So here are some answers. I got 35 miles per gallon traveling from Houston to Dallas. So remember, we're just looking at the units here, miles per gallon. This sentence would not make any sense because normal people from Houston would not travel to Dallas. But yes, as far as the units are concerned, this makes sense. Part C, I ran at a pace of 500 kilometers per hour this morning. No, in fact, I should have written that capitals N-O. No, that does not make any sense. So here's why. If you remember from the last lesson, 1 kilometer equals 0.62 miles. So 500 kilometers per hour is approximately 310 miles per hour. My car doesn't go that fast. Like planes go that fast. No, this makes no sense whatsoever because you are not running at 300 miles per hour. Part D, the price of milk in Houston is about $2.49 per gallon, or $2.49 per gallon. Yeah, that makes sense. Gallon milk is about $2.50 a gallon. Part E, Ashley can lift 1,000 grams. That absolutely makes sense. As we'll see, hopefully we'll get into, this is just a kilogram. Kilo means 1,000, and that's about 2.2 pounds. And yeah, that makes sense, but nobody walks around saying, hey, I can lift 1,000 grams. Or when somebody is at a cash register ringing up your total and they say something like, well, that'll be 572 pennies. Nobody talks like that. Just a very bored people, I guess. Yes, it's true. It would be 572 pennies, but most people say $5.72. So units, sentences can make sense, but if you're using the wrong units, it's not going to make sense to most people. So let's take a look here at some more examples. You are buying 30 acres of land at $12,000 per acre. What's your total cost? All right, so I'm going to start out with one unit here. So I'm going to start out with this 30 acres. Let me set that up. 30 acres. I've got $12,000 per acre. And what is the total cost? So over here, cost is in dollars, right? So I need a fraction, like we were learning from last lesson. I need a fraction that will have acres in the bottom and dollars in the top. And remember, we're multiplying here. Of, in fact, of, there it is. We are multiplying. So 30 acres of land times $12,000 per acre will leave you with $360,000 of purchase price. And yes, normally we do not use the actual word dollars to represent the dollar sign here, but we will just use the dollar sign from now on. Example 3. Your new neighbor bought his farm, the one next to you, 10 years ago for $450,000. If he has 100 acres of land, how much or what was his cost per acre? Okay, so here I know we had $450,000, and you can see that my unit in the top, at least, will be dollars. And I've got to do something here. I don't know what operation I'm going to be using, but over here I want dollars per acre. So since I start out with this much money, and I'm trying to get to cost per acre, I need to have an acre in the bottom, which means I should probably divide this by 100 acres. And once I simplify this fraction, I will get $4,500 per acre. And that is at a steep discount from what you are buying your farm for. You're only getting 30 acres of land for a little bit less than your neighbor paid for 100 acres of land. So it turns out buying land sooner makes sense. Here, a car travels for 350 miles for 5.5 hours. On average, how fast was the car traveling? This one's fun. So how fast was the car traveling? Fast is what we would say a rate. And a rate means you have a fraction. So this would be miles per hour. So we know we have 350 miles. And if we are trying to figure out miles per hour, we have to, as you can see here, divide by the number of hours. I'm going to pull another fast one here. 5.5 is 5.5. So if you divide these two numbers, you will get 64 miles per hour. And you can even write it like 64 mph. That's something we are all pretty familiar with. Lastly, an airliner travels 4,800 or 4,800 kilometers in 35 minutes. What's the speed? Again, speed is implying a fraction, a rate. So we know it'll be kilometers per hour. So it'll be 4,800 kilometers per 35 minutes. Oh no, this is in minutes. So we have to do some unit conversion here. Times 60 minutes per 1 hour. It's a good thing I read that. We have minutes here, but hours here. All right. So what do? We can multiply 4,800 times 60, and then we can divide it by 35 in the bottom to get roughly 8,288. 8,288.6 kilometers per hour. So I know this was on the last slide, but it says convert your answer in example 5 to miles per hour. So 8288.6 kilometers per hour. And if you remember, I've already done it once. We have 0.62 miles is equal to 1 kilometer. And that will give us the miles per hour, which is 5101 or 5,101.7 miles per hour. Moving quickly to these last few examples with price comparison. You're always finding money per unit, and this is important. Money is always going to be on top. So we want to know how much, like for example, example 7, find the cost per ounce. Cost per ounce. Money divided by some unit of vegetable oil if 24 ounces costs $2.49. So we want the money to be on top here. So we have $2.49 and we have 24 ounces, which is abbreviated OZ if you don't know. Ounce or ounces is abbreviated OZ. So this is one way to describe how much vegetable oil costs by the container, by the 24-ounce container. But different brands put out different vegetable oils, and maybe one is of a higher quality or whatever. So the best way to compare these brands is by comparing how much it will cost per 1 ounce. And essentially all we have to do is divide these two numbers, 2.49 divided by 24, and get 0.10375, and that's dollars per ounce. So one thing you want to keep in mind when we are dealing with money is that you want to round to 2 decimal places. So really we're just interested in this here. And you have to be flexible with that because depending upon which homework management system you're using, be it MyMathLab or WebAssign or whatever, it may ask you to round to different numbers of decimal places. But usually with money, we do 2. It's pretty safe to assume that you will want 2 decimal places for that. So this is about 10 cents per 1 ounce. And again, if you can break every vegetable oil on that shelf or in that section down to a cost per ounce, then you can be a more informed consumer. And you'll notice if you've ever done any grocery shopping that stores have started doing that, but oftentimes they will break it down into weird units. Like for some vegetable oils, maybe they use 1 ounce. For other vegetable oils, they may give you 8 ounces because in cooking 8 ounces is a cup. So you'll just have to be aware of what information the store is giving you in order to make the best decision. Here we go. Example 8. 20 ballpoint pens cost $3. What is the cost per pen? So again, you just want to work with the money on the top, $3 on top, and 20 pens on the bottom. So right now we're talking about pens. And if you just divide these two numbers, you can put the result in the top. So $0.15. It's already only 2 decimal places, so $0.15 per 1 pen. And these two fractions are saying exactly the same thing. It's just one is easier to understand and compare with. That's this one. And this one tells you about the product that's right in front of you. And you will pick which one makes more sense depending upon the situation you're in. Go ahead and try number 9. This one you will be doing two price comparisons. So here with 1 dozen eggs for $2.30, and then the other one would be 30 eggs for $5.50. And then we can ask this question, which is the better buy? All right, so the first thing you want to do here is compare for 1 dozen eggs, $2.30 is what you'll pay. So $2.30 for 1 dozen eggs, which would in fact be 12 eggs. And when you divide that out, it comes out to be $0.1916 or $0.1916. And again, if you round that to 2 decimal places, this digit here, this 1, tells you that you will not be rounding up. So it's 19 cents for 1 egg. Comparatively, if you go for the 30 eggs at the $5.50 price, that'll end up costing you about 18 cents per egg. And which is the better buy is completely subjective. If you're going just by price per egg, you want to buy the larger pack because you'll pay less per egg, almost a cent less per egg. But let's say you don't eat a lot of eggs and you want to make sure you eat all of them before they go bad. I think the 1 dozen for $2.30 would make more sense. Instead of buying more eggs for more price and not using so many of them would be more detrimental for you. All right, so let's take a look at a few examples of gas mileage, and then you guys should be able to go out and be successful in your homework. So, example 10, we have gas mileage. And just similar very quickly to what we've been talking about, you're always going to have some sort of distance on top and some sort of gallons on the bottom. So we can talk about miles and kilometers and even meters if you want as a distance. And then gas mileage for the denominator, the unit will be gallons. See here, 26 miles per gallon in example 10. And when we get down here, the units start changing a little bit, 55 mph, 70 mph, same thing here and here. And we'll have to see how that affects our answers here. All right. So example 10, if your car gets 26 miles per gallon, how much does it cost to drive 320 miles when gasoline costs $3.30 per gallon? So, what are we trying to figure out? How much does it cost? So, way over here, I just want cost or dollars. So, what do we know? We know that we can drive 26 miles per gallon and that we have to drive 320 miles and that we know it's this much per gallon. Oh my goodness, that's a lot to keep track of. So I think what we need to do is we should probably figure out how many gallons first. So we know if we're going to drive 320 miles at 26 miles to the gallon, what that's going to look like is we can have 320 miles over 26 miles per gallon. Now there's a lot going on here. So what's going on? We can figure out how many gallons we will have if we divide our distance divided by our miles per gallon. So total distance divided by miles per gallon will give you the number of gallons, which will be 12.3 gallons. Now that we know how many gallons are going to be used, we can multiply that by the price per gallon, $3.30 per gallon, and the units will cancel here, leaving us with 12.3 times $3.3, giving us a total of $40.59 if you round correctly. All right, example 11. Suppose your car averages 32 miles per gallon on the highway if your average speed is 55 miles per hour, and 25 miles per gallon on the highway if your average speed is 70 miles per hour. And this is a real thing. If you push your car to go harder for a longer time at highway speeds, if you push your car harder, 70 miles per hour, your MPG will go down. If you scale it back a little bit and go, like for Houston, like 20 miles under the speed limit, you'll get a better miles per gallon. So the first couple scenarios here are just asking for what is the driving time? How long will it take you to go 2,700 miles or 2,700 miles at a speed of 55 miles per hour? So I think, again, we just have to make this simple division. 2,700 divided by 55, that should tell you how many hours we're going to be working here. So that ends up being about 44 hours. Similarly, if you travel 70 miles per hour, much faster, I feel like you should get there in a shorter amount of time. Let's see if that's true. 2,700 divided by 70, that is about 39 hours. And yeah, that makes sense. We should get there faster if we're traveling faster. We should get there in a shorter amount of time. Cool. Now, this one can get a little bit wonky here. Assumed gasoline price of $3.42 per gallon. What is the cost for this particular trip at 55 miles per hour? And what is the cost for this particular trip at 70 miles per hour? So I'm going to do part C over here in red. Well, if we wanted to know how many gallons we were using, that information is way back up here at the beginning. So for 55 miles per hour, we're getting 32 miles per gallon. So how many gallons for 2,700 mile trip? We would just divide by 32 miles per gallon, giving us a total of 84 gallons, we'll say 375. So this is the number of gallons at 55 mph. So from there, we can just go ahead and multiply 3.42, $3.42 per gallon to give us a total of $288.56 for a total gasoline cost. You're going to do something very similar for part D. Go ahead and pause the video and see if you can figure out how much it'll cost to drive the same trip at 70 miles per hour. So for part D, if you run through the same process, this time we divide 2,700 by 25, because up here you get 25 miles per gallon if you travel 70 miles per hour. And that leaves you with exactly 108 gallons. 108 gallons. And again, if you multiply that by the $3.42 per gallon, all of the units end up working out just fine so that we are left with dollars, and it costs $369.36, again rounded accordingly. That concludes the lesson for 2B for contemporary math. Good luck.